In this video, I'll be walking through all the questions from the summer 2025 Cambridge A-Level Maths exam paper 2-1. It's going to be a long video. I do not want to just give you the solutions. I'm trying to teach you how to do the questions, and that takes time. Remember, we're not in the classroom, we are on YouTube, so take advantage of all their tools. There's chapters in the timeline below so you can jump to the question you're interested in. Remember to pause and rewatch difficult parts of the video and even change the speed as you need. With that said, let's start off with question 1. In question 1, we're given this equation here and we're asked to find dy dx, that's to differentiate it. So the first thing you need to recognize here is we actually have two terms. That's the 6x term and the cosine x squared plus 1 term. When two things are multiplying and you want to differentiate, one of the most common ways is to use the product rule. So the product rule tells you if y is equal to two things multiplying, u times v, then the answer is leave one of them alone, u in this case, dv, differentiate the other one. So first one left alone multiplied by the derivative of the other one plus the second one left alone multiplied by the derivative of the first one. So that's what we're going to do here. Let's see, let's jump into it. Dy dx. The first one left alone is 6x. The derivative of the second one, that's where we get a problem. I'm gonna ignore that for a moment. I'm just gonna write it like this. The derivative of cosine x squared plus 1. I'm just gonna leave it like that for a few moments. And then plus the second one left alone, cosine x squared plus 1 multiplied by the derivative of the first one. So that's just 6. Let's put the 6 up front here. This is all quite easy except for this one thing here. So let's just do this separate, okay? Let's do this. I'll do it over here and then we'll come back and finish off the question. Okay, so let me write it again as y is equal cosine x squared plus 1. What is dy dx of this guy? Because that's really what the question comes down to. You can go ahead and do this in your head if you are good at doing things like this in your head. I'll show you how to do it using the chain rule. So let me remind you what the chain rule is. When we have something complicated like this, instead of finding dy dx, let me right here. Instead of finding dy dx, it might be easier to find dy d something. So substitute something in. We usually use u. Use u a lot. Dy du. And we fix that little cheat by then differentiating the u and multiplying. That's what the chain rule tells us. So in this case, if we think of this as cosine u, just something simple in here, the chain rule tells us, well, it's easy then. We differentiate with respect to u. So what's cosine u? What's the derivative of cosine u? It's just minus sine whatever this u is. And I'll just leave it as x squared plus 1. I've run out a little bit of room where I've wrote my chain rule, so let me just rub that out. Then the chain rule, which I've just rubbed out, tells us this is fine if we fix our cheat by differentiating what we replaced. So if we differentiate what's in here and multiply it, we just multiply it by 2x and that's it, just multiply it by 2x. So this all cleans up to minus 2x sine x squared plus 1. And you can do that in your head. It's not too difficult. We're just saying the derivative of cosine is sine multiplied by the derivative of what we cheated with, basically. Let's write that in here. 6x multiplied by minus 2x sine x squared plus 1 plus the 6 cosine x squared plus 1. Clean all this up, we get minus 12x squared, there's two x's here, sine x squared plus 1 plus 6 cosine x squared plus 1. I think that's all they wanted then. They just wanted an expression for this. Didn't want you to do anything with that. If you are finding my videos useful and would like to help the channel out, on top of liking and subscribing,
Probably the best thing you could do is to tell other people doing the exam about my channel. Maybe you could share this video in a class WhatsApp group. Then if you feel I've really deserved it and you would like to buy me a coffee, you could become a member on YouTube or on Patreon. You should find links to that in the description below.
That's it for question 1. If you have any follow-up questions, let me know in the comments. I'll do my best to get back to you. Thanks for watching and have a great day. Question 2 starts off by them asking us to use logarithms to solve this inequality here. 4 to the power of x is less than 0.05, and they want us to give our answer to 3 significant figures. Okay, quite straightforward. What you need to remember about logarithms is they're the opposite to powers. When something is the power of something, a logarithm is what destroys it. That's what the opposite is. We very often use e to the power of something, and the opposite is the natural log. Natural log destroys e. But logs are much more general than that. The opposite to this power here will be the log to the base 4. The opposite to this power is log. This guy is identical to log to the base e. It's just a shorthand for it. So the opposite to this guy is log to the base 4. So let me show you how we would use that. We take log to the base 4 of both sides. We're being equal in that case. Log to the base 4 of the left will look like that. Well, let's put a bracket around it. And log to the base 4 of the right looks like that. Now the reason I picked this is because log to the base 4 destroys this 4. Just like natural log destroys this e. Log to the base 4 destroys this 4, and on the left all we're left with is the x. X is less than this. You can put this in on your calculator. If you go ahead and do that and get to three significant figures, not 3 decimal places, this comes out as minus 2.16, and that's the answer for part A.
If you are finding my videos useful and would like to help the channel out, on top of liking and subscribing, probably the best thing you could do is to tell other people doing the exam about my channel. Maybe you could share this video in a class WhatsApp group. Then if you feel I've really deserved it and you would like to buy me a coffee, you could become a member on YouTube or on Patreon. You should find links to that in the description below.
Okay, I'll leave the answer for part A up here because we're going to use that again in part C. But for now, we're going to part B. Part B gives us this inequality with an absolute value in it. There's 2 quite common ways to solve absolute values. Because it's quite an early question, I have a little extra time, I'm going to do it both ways. The first way I'm going to show you is the way I think students should do it. It's the smarter way, but it's also the shorter and easier way. But it's just the way that tells you more about it. I draw it. And you should draw as much as you can in maths questions and exams. It helps you understand and think about stuff. So how do you draw an absolute value of something that looks like this? First of all, just recognize that inside this absolute value, we have 3x plus 8. If I wrote y equals, that's just a straight line. We can draw lines that look like that. That would be 8 is the y-intercept. So say here is 8. And the slope would be 3x. That's quite steep. It's going up like this. The y-intercept, we can just rearrange it and find y is 0, 8 becomes minus 8. We get that x is equal to minus 8 over 3. It's minus 8 over 3. We could draw this line here. Now the absolute value, how it works is when it's bigger than 0, it looks just like that line. It doesn't change anything in here. But when it's less than 0, anything that's a minus number, it makes it positive. So what it looks like is, it looks like it just bounces like that. That's how you draw an absolute value. We'd have these are the 2 important numbers there. But let's read what this says. It says the absolute value of this is less than 9. Where's 9? 9 is right here. And 9 looks like a straight line. So again, reading this in the picture, it says When is the absolute value less than 9? Well, it's less than 9 in between these two parts. In between these two numbers is when it's less than 9. So you can forget the inequality. What they're really asking is, what is this number here? What's the x number here? What's the x number here? And you don't need an inequality for that. That happens when this line hits this line. That happens when 3x plus 8 equals 9. That will find this point here. Rearrange this, we'll get 3x is equal 1, x is equal 1 over 3. This point is 1 over 3. The other point is nearly as easy, except we just need to remember what this line looks like. It actually looks like minus 3x minus 8, because that's what the absolute value does. When it's less than 0, it just multiplies everything by a minus. So instead of 3x, we get minus 3x. Instead of 8, we get minus 8. And that's what that looks like. You can even see it would hit down here at the minus 8 y-intercept. And slope would be minus 3. It's going down quite steeply. Sorry, so this is equal to 9. We'd get minus 3x is equal to 17. We'd get x is equal to minus 17 over 3. That's what this point is here. The answer to part B is simply x must be between these two numbers. X must be less than a third and bigger than minus 17 over 3. That's your full marks for part B. But I am going to go ahead and do it again here in a slightly different way. Okay, here's how I'm going to set up the question in a slightly different way. I'm going to split the world in two. I'm going to say the absolute value does two different things. When 3x plus 8, when that's bigger than 0, it does nothing. And when 3x plus 8 is less than 0, it multiplies everyone by a minus. So in this world, we'll have x must be bigger than minus 8 over 3. And in this world, x must be less than minus 8 over 3. So if we had the world as a number line, let's write a number line down here, 0. This part of the world deals with everything over here, and this part of the world deals with everything over there. Okay? When it's bigger than 0, absolute value does nothing. So we just get 3x plus 8 is less than 9. We can rearrange that. We get x is less than 1 over 3. That's it. When we're in this part of the world, we find out that x is less than 1 over 3. And we get, let me shade in here, we get between 1 over 3 and minus 8 over 3. That's a new number. It only appears when you do it this way. We get that. So that's not quite the right answer, because there's more of the world to check. We've checked this part of the world. We need to check this part. Sometimes the answer is only in one part and the other part just doesn't make sense. But this wouldn't both make sense. So when x is less than minus 3 over 8 over 3, when what's in here is less than 0, what happens? We get minus 3x minus 8 is less than 9. Because remember, the absolute value would have multiplied everyone by a minus. Rearrange this, we get, I'll just skip to it because we just did it over here. We will get x is bigger than minus 17 over 3. So what does that look like on this world? It's over here, it's minus 17 over 3. It's everything between here and this part here. And if we combine both of those together, we have everything between, so yeah, combining both this information together, you can see it quite nicely on the picture. X has to be, less than 1 over 3 and bigger than minus 17 over 3. That's two different ways to do it. One is quite a mathematical way. If I was telling a computer how to do it, I'd tell it to do this. I'd tell it to split the world into two parts, solve both parts, combine your answer. That's what I tell. If I'm telling a human, which hopefully I am, although maybe AI is learning from this video, if I was telling a human how to do it, I would tell it, think of what it looks like and try and simplify the the inequality down to an equals. Make it easier to solve. So that's the two different ways to do part B. Either way, the answer is x is between minus 17 over 3 and 1/3. Finally, for part C, it's only 1 mark for this. They want you to combine your two answers. This is your answer from part A and your answer from part B, and tell us how many integers satisfy both of them. Remember what an integer is. It's a whole number. 1, 2, 3, 4, or a 0 as well. -1, -2, -3. Let's see which of them fit in here. 17 over 3, that's about 5 point... yeah, that is 5.66 or minus 5.66. So 5 is here, or -5. -4, that's not big enough drawing. -3, -2, -1. Oh, sorry, I got off track there. Let's say -3, minus... Where was this guy? -2 would be here, -1. All of them are in this. But this guy only has... doesn't have -2 in it. Doesn't have -1. -2 is not less than -2.16. -1 is not less than. 0 is not less than. So, but -3 is -4, -5, -6, -7, -8. All of them are less than. The only place they all agree is at -5, -4, and -3. I'm sorry, I don't think I explained that too well. Hopefully you were okay at that last part. It's just what whole numbers are fit in here. It's -3, -4, -5, -6, -7, all the way to infinity. What whole numbers fit in here? It's -5. Yeah, let's look at this one. The only whole numbers between these two is -5, -4, -3, -2, 1, sorry, -1, and 0. They're the only ones, and the only time they all agree are at these 3 numbers. That's your full marks for for question 2. Okay, if you have any follow-up questions, if you want me to try and explain part C again, maybe, let me know in the comments. I'll do my best to get back to you. Thanks for watching and have a great day. In question 3, we're given 2 different equations and we're asked to sketch them on a single diagram. Now there's only 2 marks for this, so you shouldn't spend too much time on this question, but I am just going to take my time to teach you how to do it. If you just know what a function like this looks like and you just know what this function looks like, you're fine. That's okay. I'm gonna hopefully teach the student that's okay at remembering some functions but not quite good at remembering them all. So here's how I would do this. I'm going to draw lots of pictures before drawing the final one. First of all, what does forget this, what does e to the power of x look like? This is something you do need to remember. Some of the basic functions, you do need to remember what they look like. It looks like this, goes up quite quickly and it hits at 1. Think of, you can always find this point quite easily by putting 0 in. If you put 0 in here, anything to the power of 0 is 1. It'll look like this. Let's draw a few more. What about e to the minus x? I'm just trying to get it closer to looking like this. E to the minus x. Think of what happens when you change this sign. When I put in minus 1,000,000, I get this. When I put plus 1,000,000, I get up over here. So if I put in minus 1,000,000, that'd be minus minus, I'll get the plus, I'll get whatever's up here. So I'll actually get something up there. If I put in 1,000,000, I'll actually get what minus 1,000,000 would get here. I'll get something down here. It's just, we get the opposite to that, like that. That's still at point 1. Stay drawing here. What about e to the minus 2x? It'll look identical to this, except it'll just go a little steeper. Instead of going up steep, it'll go up even steeper again. And then finally, we'd have 3e to the minus 2x. It will go up steeper again. Multiply everything by 3. That'd be a 1. This will now be a 3. That's really the idea we want to get. And it's okay if you're able to do that straight from the beginning. Alright, this one's a little easier. First, we need to remember what secant is. Secant is equal to 1 over cosine x. Again, it's okay if you just know what secant looks like, but I'm not very good at that. I'm going to draw cosine first. Yeah, cosine x. Cosine x looks like this. And we'll do it both ways out here. So what does 1 divided by this look like? This is a 1 here. 1 divided by 1 is 1. 1 divided by, say, a half, that's 2. So it actually goes, when this goes down, this goes up. 1 divided by 0, and that's the real clue. 1 divided by 0 goes off towards infinity. So we get this shape here. 1 divided by minus 1, we get a minus 1. 1 divided by 0, again, goes off to infinity. We get this shape here. Let me just draw a few of these in. I probably haven't lined them up. This 0 should be, yeah, this I haven't lined it up very well. We get this sort of shape. This is what secant x looks like. We really want to combine this with this one here. It's not as hard as it looks because they only wanted us to draw between 0 and pi over 2. This is, yeah, let's go up to this one. This is pi. No, that's not right. It is. That is pi, and this is 2 pi. Pi over 2 is here. That's pi over 2. That's, at this point here, that's pi over 2. Pi over 2 is just the number. What's that? 1.57? Whatever it is. It doesn't really matter. Just pi divided by 2. Somewhere here. It doesn't really matter because the shape just stays the same. So you combine these two. Let me squeeze the actual answer in here between pi over 2. They would want this shape here starting at 3, and they would want it to come down. That's it. And they would want this shape here starting at 0. Starting at 1. 1 here, and they would want it going up like that. Actually, that can go off to infinity there. That's really all they're looking for those 2 marks. They want to see pi over 2. Sorry, let's say come down like, let's have it like that maybe. They want to see pi over 2. They want to see the number 3. They want to see the number 1, and this going straight up like that. That's your full marks for 3 part A. Hopefully that helped a little. I'm sorry if it was a waste of your time, but if it was, you probably just skipped it.
If you are finding my videos useful and would like to help the channel out, on top of liking and subscribing, probably the best thing you could do is to tell other people doing the exam about my channel. Maybe you could share this video in a class WhatsApp group. Then if you feel I've really deserved it and you would like to buy me a coffee, you could become a member on YouTube or on Patreon. You should find links to that in the description below.
Just to reiterate, part A, this is the full answer for part A. This will get you full marks. I'll leave it there because I'll reference it again as we go on. Okay, for part B, they want you to show that the x coordinate, the point of intersection here, is x is equal, let me write that out, is x is equal a half natural log of 3 cosine x. They want you to show that. Where did that come from? The clue here is the intersection of these 2 curves. It's when this equals this. They want you to put this one equal to this. Sorry, I've changed this one, by the way, from secant to 1 divided by cosine x. I just do that all the time, and it's clear it's what we should do because it's cosine is in what we need. In fact, I never use secant. I just don't like it. So let's just put them together. We get 3e to the minus 2x is equal 1 over cosine x. They want you to rearrange this so x is on its own and it equals all this. You have 2 choices of which x to get on its own. This one, but that means getting rid of cosine, and we want cosine, so that's probably not the one. Or this one, and that means getting rid of e, which there's no e up here, and when you get rid of an e, a natural log appears. So it's this x they want us to get on its own. You've a couple of choices how to do this. One thing that jumps out at me is rewriting it as 3e to the 2x like that is equal 1 over cosine x. Multiply across. So we get on the left 3 cosine x, which is good because we want 3 cosine x, is equal to e to the 2x. Now we can just take the natural log of both sides. Let me write this side first. Natural log of e to the 2x is just 2x. Natural log destroys the e. And natural log of this side is natural log 3 cosine 2x. no, it's cosine x, sorry, I don't know where 2 came from. And x, oh yeah, 2x over here. X then is equal a half natural log 3 cosine x, just like they asked for. That's your full marks for part B. In part C, they ask you to use an iterative formula based on the equation in part B. And to find basically to find the answer. To tell you they wanted 3 decimal places, but give each iteration to 5 decimal places. This should all be sparking a bell because this question comes up every year. You should have studied it, you should have practiced them. They're slightly different time and time again. Usually they give you the iterative formula. In this case they haven't, they've just given you this. So you just need to change this ever so slightly. It just becomes xn plus 1, or sometimes some people use xn here, is equal to a half natural log of 3 cosine xn. Again, some people use xn and n minus 1. I just use n plus 1 and n. Just a slight difference. Either is an iterative formula. That's the first thing they want you to do. I think they'll probably give you a mark just for doing that. And from this point, it should be the same as you always do. What you want to do is you want to make a guess at an answer. Sometimes they give you that first guess. They haven't in this case. You just want to make up a guess, and then for x1, your next guess, this formula will give you your next guess. This formula will be a half natural log 3 cosine whatever your first guess was. And it'll give you your second guess. You do it again, x2, and you put it in the formula again. Your second guess goes into the formula, it gets you your third guess. You stay going, and this formula will give you a better and better guess each time. Usually it takes about 3 or 4 guesses. The number I started with, it actually took me 10 guesses, which is a little annoying. I started with, so once your number is anywhere between 0 and 1.57, like that's all you really need. So 1 could be your guess. I just took somewhere in the middle. I think I started with 0.75. Honestly, any number. We'll get different numbers as we go through the question, but we should all get the same final number. So this is your first guess. You put this into this formula, and the calculator will spit out your second guess. Again, you could call this x1 if you want, and x2. I just start with 0. It must be the way I learned just. So when I put that in, I get as my next guess 0.39311. That's five decimal places they asked for. But I also like to write in 3 decimal places, because that's what our final answer is going to be. When this number repeats itself, when your next guess is the same 3 decimal places, you've gone far enough, and that's a good enough answer. Okay, you need to put this out every time. Like I said, it's going to take 10 guesses, so you need to put this in your calculator 10 times, which is a bit annoying. But there is a quicker way. Let me write it here. If your calculator has this as the final answer, or this, I often just put this one, 0.75, and I press equals. This is now remembered as your answer, or in this case, this is your answer. It doesn't really matter. What you can do, you can put in your calculator a half natural log 3 cosine, and in here, instead of putting in the number you want, you put in, there's a button on your calculator that just says answer, and what it will do is it'll put your previous answer in, and so you will just get out, you're not saving yourself anything yet. In this case you'll get out 0.963 or 50963 or 0.10 to 3 decimal places. Now the advantage of doing this in your calculator is if you press equals again, let me put it down here, x3, if you press equals again, it will automatically remember this is your last answer and this is the formula they're dealing with. So it'll just give you, you can just press equals a few times and you'll get the answer you need, although you do need to show the examiner each number. So in this case I get 0.48135, which is 0.481. These aren't repeating yet, they're in fact miles off each other. So I just have to stay going. You know what, let me write out all the numbers I got, and then I'll talk about what we found. Okay, so this was a nasty question. It's only the second time I've ever seen a question come out this long. It took a lot of writing to do. I really wish I had guessed 0.5 because that's quite close to the final answer. So here's what happened. Each number I got, they never repeated. So I never thought, oh, I'm at the right answer. 0.487 did repeat, but with 88 in the middle. And then 88 repeats. So I know the answer is around there. It keeps jumping around this number. I know it's roughly the right answer. But until I get two of them repeating, I don't know where exactly the right answer is. But that's what you should have got no matter what you started with. You should have finished off with 0.487. If you did start as 0.5, I guess it would have been a little quicker. But not really. I guess I was at 0.5 on my second guess. So honestly, it's just one of those, they sort of, it just takes a while to narrow in on it. Okay, that's it for question, what are we on? Question 3. If you have any follow-up questions, let me know in the comments. I'll do my best to get back to you. Thanks for watching and have a great day. In question 4, we're given this diagram and this equation, and we're asked to find the exact coordinates of the maximum point, sorry, the x coordinate. So we really just want the x number of this maximum point here. Of course, we see maximum point, we hopefully are thinking dy dx equals 0. Dy dx equals 0. That's going to get you part of the way to 1 mark just by writing that down. So what they're asking us to do is to differentiate this function here. Let's do it over here. It's not that easy. Some students can do it in their head. You know what I'll do is I'll differentiate this first one here really slowly using substitution, and then I'll do them both a little quicker. I'll show you the shortcut that might do both of them. So forget that for a moment. Let's just come over here and look at a whole new function, 6e to the 2x. To differentiate this, it's a little complicated. We know how to differentiate e to the power of x. It's really easy. It's just e to the power of x. So if I change this up and I substitute some of this, I put u is equal to x. You can do all this in your head. You wouldn't usually write all this. And this function becomes y is equal 6 to the e to the u. Using chain rule, this is quite easy to differentiate. Dy dx is equal to dy du multiplied by du dx, because these cancel each other. It's the same thing here. And what this really says is differentiate this with respect to u, it just becomes 6e to the u, and then differentiate u with respect to x, that just becomes a 2. Putting all that together, we get 12e to the power of u, which is e to the 2x. Now we could have done that quite quickly by just saying the derivative. Yeah, let me write this again. This is how I would do this. I would just say the derivative of e is just leave it alone. It's just 6e to the 2x. Except I have to multiply by the derivative of what I just forgot was there. I forgot this was complicated. And if I multiply by the derivative of that, I get my final answer. So I just multiply by 2. Or usually I do all that in my head and just say 12e to the 2x. So I'd look at this and I'd say, well, let me do this half slowly. 6e to the 2x multiplied by a 2. And that 2 is coming from the derivative of here. Doing this one here is minus e to the 3x multiplied by 3. That 3 is the derivative of up there. That's how I do it. And if you wrote this, it'd be fine. The examiner would know where you're getting this shortcut from, or that's the longer way to do it. Clean this up, we get 12e to the 2x minus 3e to the 3x, and all that's equal to 0 because we're looking for the maximum point. So let's rearrange this. 12e to the 2x is equal to 3e to the 3x. There's a couple of ways to solve this, but nicely later on in the question we have to solve something similar again. So I'll do it one way now and one way later, and we'll see what we get. You'd be forgiven if you see e, just think, well, natural log destroys e. So I take the natural log of both sides. That's 12e to the 2x is equal natural log of 3e to the 3x. The problem, natural log can't destroy this e because the 3 is in the way and the 12 is in the way, so that's a slight issue. But we just look up our rules for logs. When a log has two things multiplying inside it, it works quite nicely. It's just log 12 plus log e to the 2x is equal log 3 plus log e to the 3x. That works out quite nicely. That's log 12 plus 2x, because the natural log and the e now do destroy each other, is equal log 3 plus 3x. We clean that up. I'll do it over here. All the x's on one side, all the natural logs on the other. We get 3x, well, let me write out. 3x minus 2x is equal, let's see, natural log of 12 minus natural log of 3. That'd be x is equal, well, natural log, the same rule that broke these apart, can put them back together. Take away is just like divide. This is the natural log of 12 divided by 3. You could have also just 12 divided by 3 all the way back here as well to get a 4, to get your final answer as well, natural log of 4. That's your answer for part A.
If you are finding my videos useful and would like to help the channel out, on top of liking and subscribing, probably the best thing you could do is to tell other people doing the exam about my channel. Maybe you could share this video in a class WhatsApp group. Then if you feel I've really deserved it and you would like to buy me a coffee, you could become a member on YouTube or on Patreon. You should find links to that in the description below.
Now for part B, they want us to find the shaded region in here. Let me just write down the answer from part A. That's natural log of 4. This would have helped me when I did the question first, because I made a big mistake that I'm guessing some students probably made. Let me write out the mistake I made and see if you notice it too. Okay, so the shaded region of this. Hopefully you're thinking integration. So what we're going to look for here is the integral. I have to check my notes to remember the formula. 6e to the 2x minus e to the 3x. We need to integrate this to find the area. We need to integrate it between 0 and natural log 4. Do you see the mistake? I'm guessing one or two of you probably made the same mistake as me. It's not between 0 and natural log 4. It's between 0 and whatever this number here is. I think the examiner probably did that on purpose. They knew your answer from part A would be in your head. You'd think, just put it straight in. I messed up. I did it through and was just double checking my answer and I was like, what happened? I instantly see where that. So the first thing you need to do before doing this integral, you need to find what this number is here. So we do that by putting y equals 0. So we know y is 0 and we know y is equal to 6 e to the 2x minus e to the 3x. So we just need to solve this. It's quite like what we did in part A. Move this around, we get e to the 3x is equal 6e to the 2x. Last time I got natural log of both sides. Let me do this one a little different. Let me play around with the powers this time. This is the same as e to the x to the power of 3. And this is the same as e to the x to the power of 2. I'm just using the rules for powers instead of the rules for logs. If I divide e to the x squared over, let me write it out a bit slower. E to the x, there's 3 of these, and I'm going to divide by these two. E to the x, there's 2 of these. They cancel in, they equal 6 first of all. They cancel in and we're just left with one of them, e to the x. 2 cancels in and we're just left with e to the x to the power 1. E to the x to the power 1. Just take the natural log of both sides now. Natural log of 6 is equal x. That's the number we're looking for here. Natural log 6. That's the number that should be up here. Now we can start finding the area. Alright, let me clear this bit off and I'll continue to do the question I should have done. Just like I did previously, you can do this quite quickly in your head. You're actually going to just end up leaving this alone and dividing by the derivative up here. But let me do it slowly one more time. I'll do the first one quite slowly. Again, I'll use substitution. The idea that u is equal to this 2x up here. And you could do it with 3x as well. But again, we'll do it quickly after showing you the first time. If this is substitute, the derivative of this, which we're getting so I can find out what to replace dx with. Although it's a bit confusing here because what I'm actually just doing is half of this. I'm ignoring that guy. Hopefully that's clear. This is equal to 2. When this is just a constant, in differentiation it works no matter what, but in integration it only works when it's a constant. You can just divide by it because all the x's are gone in this second one. So that'd be dx is equal to a half. That's where we get divide by 2 du. So yeah, let me change this here. All I'm doing is this right now. And that would become the integral of 6. Well, the 6 can come outside the integral. 6 e to the u multiplied by a half du. I'm replacing the dx with a half du. And again, the half can come out. We get 3 integral e to the u du. The integral of e to the u is just e to the u. That's the special thing about e. Its integral and derivative is the same as itself. So the answer is e to the u or e to the 2x, because that's what u is. So the integral of this guy is just this. Let me do the whole question again. This time I'll do it quickly in my head using what we learned here. So we were doing the integral between natural log 0 and natural log 6 of, let's say, 6e to the 2x minus e to the 3x with respect to x. So the integral of this is just 6e to the 2x divided by the derivative of whatever's up here. So the derivative of 2x is just 2. Minus e to the 3x divided by 3, because it's the derivative of 3x. And this is just evaluated between 0 and natural log 6. We can clean this up slightly. 3e to the 2x minus 1 over 3e to the 3x. Again, this is evaluated between 0 and natural log 6. So let's just start filling this in. Natural log 6 goes in here. 3e 2 times natural log 6 minus 1 over 3e 3 times natural log 6. And then we put 0 in and we take that away. Minus 3e 2 times 0 is 0. Minus minus is a plus. 1 over 3e to the power 0. We need to do a little bit of work with the logs. 2 natural log 6. Your calculator will tell you, but it's also, this 2 can move in and become a power up there. So it's actually just natural log 36. E and the natural log destroy, so we're just 3 times 36. Do you see where I'm getting the 36 there? That's 6 squared. Same here, it's 6 to the power of 3. So this is minus 1 over 3 e to the natural log destroy, and we'll just have a 6 to the power of 3, which I'll have to just double check my notes. I want to say 200 and, yeah, there it is there, 216 minus 3 plus a third. I guess we put everything over 3. This over 3, multiply up here by another 3. That's already over 3. This over 3, multiply this by another 3. And put all this together. This be 9 multiplied by 36, which would be 270 plus 9 sixes is 54. 324. Apologies if that's wrong. I'm going to correct it in a minute because I've just used the answer I got down there. But 324 minus 216 over 3 minus 9 over 3 plus 1 over 3. Let's see, there's 100 between these two, plus another 8. So 108. Take away 9 is 99. Plus 1 is 100. So I think I did have the right number here, because that is the final answer that I have there. 100 divided by 3 is the total area between 0 and natural log of 6. Okay, they wanted the answer in the form of p over q, where they're both integers. That works fine. That's the answer to question 4. If you have any follow-up questions, let me know in the comments. I'll do my best to get back to you. Thanks for watching and have a great day. In question 5, we're given a polynomial with some missing pieces of information. A and B is missing. There's an A here, a B here, and again an A here. To find those two pieces of missing information, that's what they ask us to do in part A. They give us two clues. They tell us 2x minus 3 is a factor, and they tell us if you divide by x plus 1, you would get a remainder minus 15. There's two ways I can see to do this question. One of them is my favourite way to do these questions, but I won't do it here because it's a little longer and a little messier. That's dividing this in to this. I've always just liked dividing polynomials. I think it's cool. So if you divide this in, after you do all your work, you remember your work of dividing in polynomials, at the end what you should get is 0, because this is a factor. It should have no remainder. What you'll actually get is like A's and B's equal something. That'll give you an equation in A and B. And once again, so you move on and you hope to get another equation from this one. If you divide this in to this, what you should get is minus 15, but what you actually get, well, what you'd expect to get is A's and B's again. You'd get two equations in A's and B's and you solve it. Actually, it works out really nice when you divide this one in and you just find out what B is. But the way I'm going to show you also works out nice. The way I'm going to show you is using these facts as well. When you have a factor, what it actually means is if you put this equal to 0 and solve for this. Well, let me do it with both of these because we're going to put both of these equal to 0. If you put both of these equal to 0, this one you'd get x is equal 3 over 2. And this one you'd get x is equal to 1. This one will have a remainder 15. When you put these numbers in, these roots to these factors as it were, when you put these numbers in, p 3 over 2, this is a root, so you should get 0. But when you put this number in, if you know what the remainder is, when you put this number in, p1, you will get the remainder. And if you know the remainder, you can just write it out. Knowing this here is the key to doing this question quite simply. Again, as I just said, this one will work out quite nicely, but I don't know that yet. So let's go ahead and do this one first. Put 3 over 2 into everything here, and I now know the answer is 0. 3 over 2 into this is 27 over 8 times A. Plus 3 over 2 into this is 9 over 4, so that's a 9 over 4 times B. 3 over 2 into this, we get minus 3 over 2 times A minus 24 equals, minus 15. You could clean this up. There's A's together here. Multiply everyone by 4 is what I do to get 8 on the bottom row. Combine the A's together. I've done all that here, so to save myself a bit of time, you'll get 15A plus 18B is equal 192. That's from the first piece of information. What I'm expecting now to find is another equation in A and B when I do the second one, and I'll have a simultaneous equation. That's a very common thing to happen in these questions. It works out a lot nicer. I guess I have lots of room down here to do this. If I put 1 in up here, I'll get A, I'll get plus B, I'll get minus A. I'm just putting 1 cubed, 1 squared, 1. They're all 1. Minus B, minus 24, and I know that the answer is minus 15 because that's the remainder at that point. That's just a theorem in maths. Let's see, the A's cancel. We're left with B is equal 24 minus 15, or B is equal to 9. So we don't have a simultaneous equation. It's actually, we just know what B is. We put that in over here, we get 15A plus 9 times 18 is 118 minus 18, so 162 equals 192. A is equal, this minus this is 30, divided by 15 is equal to 2. There are your two answers. A is equal to 2, or B, and B is equal to 9. That's full marks for part A.
If you are finding my videos useful and would like to help the channel out, on top of liking and subscribing, probably the best thing you could do is to tell other people doing the exam about my channel. maybe you could share this video in a class WhatsApp group. Then if you feel I've really deserved it and you would like to buy me a coffee, you could become a member on YouTube or on Patreon. You should find links to that in the description below.
In part B, they say hence factorize px. First of all, importantly, the word hence there matters. Hence is telling you use what you just found out. That means use the fact that A is 2, B is 9, and again A is 2. They want you to fully factorize this. If in part A you had done the long division that I suggested you could do, you'd be mostly done because half the work would be done for you for this, but it's not too hard. Anyway, we still know this is a factor. So to factorize this, we know part of the answer. It's 2x minus 3. That's part of the answer. That must multiply by something to equal this. And what you can do is, what you usually do in this case is you put in like a x squared plus bx plus c. I guess maybe you shouldn't use a and b because it was already used before. But anyway, you need to know that it's a quadratic because you have an x here, you want to get an x cubed, so you need an x squared. So this would be a good guess to make. What you can do here is multiply this by this, get all the x cubes together, all the x squares, all the x's, all the numbers, and put them equal to up here. You can solve what all of these are. And the thing is, it's actually quite easy to solve for A and C though. And you wouldn't even bother putting them out because 2x multiplied by what x squared is equal to 2x cubed. Must be a 1 here, or we just leave it out. It's done. That's the only way we get x cubed. It's only these two numbers involved in this one. And equally so, this last guy is only involved with this one and this one. What number must multiply by minus 3 to get minus 28? It must be an 8. So you're actually half your work is done. We're only trying to find out what this is. And let me rub out the B. It might be confusing there. I guess I'd put any letter you want there. A, B is fine. Let's just use C because it hasn't been used yet. Again, you could just multiply this by all of this and equate it to one of these two that we haven't used yet and find out what C is. You don't have to do all that though. You could just use one of these. For example, how do you get an x squared? How do we get an x squared? It must come from an x times an x or an x squared times a number. That's the only way an x squared appears out of all of this. So using that fact, I know this 9 must equal this x by this x. That's a 2 times c. Combined with this number by this x squared. That's a minus 3. Or you can leave all the x squares in if you want. They just disappear. So 2c must equal 12. A c must equal 6. This c here must equal 6. You're not finished. You've partially factorized it. They said factorize it completely. Let me write this again down here. 2x minus 3 times x squared plus 6x plus 8. You've partially factorized it. You can still factorize this part here. If you're not good at factorizing quadratics, I know a lot of students aren't, use the minus b formula. It will help you do it. Or use a fancy calculator. It will also help you do it. Check if that's cheating on the Alevel. Might be, so be careful on doing that. How do you factorize this? What two numbers make x squared? That must be x and x. Two numbers that make 8. 8 and 1 or 2 and 4. Which of those would work well to get a 6? 2 and 4 would. And let's just double check everything then. 4x plus 2x, that would work. And plus 2 times plus 4 would get plus 8. That would work out. Let's write in this last one here. This is your answer to part B. This is px fully factorized. This is still px still equals that. In part C, they want us to solve the equation p of this equals 0. you would be tempted to, so they gave us px earlier, I have it still down here. You would be tempted, instead of x, to put this number in everywhere. That'd be a bit of a mess, and you hopefully after a few minutes you go, hang on, this is a lot of work and there's only 2 marks. So there is a trick involved there. Well, let me first just rewrite this. I hate cosec. This is just 3 divided by sine theta. That's all that means. That's 1 divided by sine, and the 3 is still multiplied, equals 0. The equals 0 is the important thing. What happens when px equals 0? We have an answer for that. We know x is equal to 3 over 2, or x is equal to minus 2, or x is equal to minus 4. When this equals 0, it's really easy to solve because we factorized it. So when this is equal to 0, it's really easy to solve. It just means that this 3 over sine theta, instead of x, is equal to 3 over 2. Let me split the world into 3 parts. Or 3 over sine theta is equal to minus 2. Or 3 over sine theta is equal to minus 4. That's all this tells you. When it's equal to 0, it means we can use this factorization very, very easily. Rearrange this, we would get sine theta is equal to 2. Sine theta would come up here, 3 would go down there, 2 would come up here. Try it out, it would equal to 2. This one here, sine theta is equal to minus, is that right? Minus 3 over 2, and this one here is sine theta is equal to minus 3 over 4. They'd be the 3 ones you want to solve. At this point, you also want to be thinking, they told you the answers between 90 and 270, but something else should be jumping out at you as right or wrong here. To help you out, let me draw sine. Sine looks like this. This is what sine looks like. When is sine equal to 2? It never is. That's 1. And this is minus 1. Sine is never equal to 2. This should have jumped right out at you as being impossible. There's no answer at this part of it. But that's okay, we have other options. When is sine equal to minus 3 over 2? That's minus 1.5. It's all the way down here. That's never, it never hits. It never hits up here. This is also an impossible answer. We're only left with this one here. When is it equal to minus 3 over 4? Well, that is possible. It's down here. Let's put that dotted line in. There's lots of answers for it. Here's one, here's another. There's millions, there's infinite answers to this. If you put this in your calculator, theta is equal to the inverse sine of minus 3 over 4. You'll get out the answer minus 48.6. If you leave this as your answer, you're going to lose mark. I assume they'll give you 1 mark for all the work you did here, but they're not going to give you 2. This is not the answer they wanted. They told you, I never wrote it down, but they told you the answer was between 90, theta is between 90 and 270. So they didn't want you to just use your calculator, they want you to use your brain. Calculator found this answer here. They wanted to make sure you only looked between, let's see, here and here. That's 90 and 270. So the only answer they're looking for is this one here. How do you find it? You use your brain a bit. How far away from the 0 point is this one? This one here, it's 48.6. So that means this point here must be 48.6. This is 180. So 180 plus 48.6 is the answer you're looking for. So the answer is, I have it written down here, 228.6. That's the answer you're looking for. Just in case you're wondering, this answer here, because maybe you have a fancy calculator that will shoot out lots of answers. This answer here would be 311.4, and I guess they start repeating then. This one would be 360 added to this, which I don't know, is 320, 312.
something like that. If your calculator does give you all those, all you need to do is throw out the ones that don't fit in here. So yeah, just to write out a few of them. Minus 48.6, 311.4. Maybe your calculator shoots out a lot of answers. Just you need to put a line through the ones that are wrong. This is the only valid one in the range they ask for. Okay, that's it for question 5. If you have any follow-up questions, first of all, let me know which part you're talking about. Lots of students asked a question about a 20-minute video, and I'm like, what? It was 3 years ago. What part are you talking about? So please help me out on that. Thank you for watching and have a great day. In question 6, they give us a set of parametric equations. First, let me talk quickly what a parametric equation is and why it's useful. First, it allows us to draw a function that can go back over itself. That's one way I like to think of it. This might not be a proper definition of it or anything, but what's really good for is adding in an extra variable. It's no coincidence we usually use t here. If you think of x and y as coordinates of something, t could be time. So now instead of just saying here's a curve, what we could be saying is there's a boat or a spaceship or a particle or anything here. At time 0 it's here. At time 1 it's here. At time 2 maybe it's over here. It doesn't have to be quite linear like that. At time 3 it could be here. Time 4 here. At time 5 it could have made it all the way over here, went really fast all of a sudden. It can tell us a whole new set of information, these parametric equations. That's the main reason it's useful. And in this world though, we're still interested in its slope here, it's the derivative of it. The dy dx, that's still interesting information to us. We're also sometimes interested in dx dt, the speed in the x direction, dy dt, the speed in the y direction, but we could be interested as well in the actual just slope or gradient of this curve for lots of different reasons. Okay, and that's what this question is going to be about. They want to know dy dx. Now, this comes up so much, I hope most of you remember this, but dy dx is simply equal to, I always write it like this, dy dx is equal, it's just the chain rule. You can add anything you want here. In this case, I'm going to add dt, because we're dealing with t's here. If you want to find dy dx, you can just find dy dt, that's something you can do, because I can't just find dy dx, there's no x's in here. But I can find dy dt, I can differentiate this with respect to t. This one though is a bit of an issue. Differentiate t with respect to x. You'd have to rearrange this, get t on its own. It seems a little hard, but it's good news. You don't have to do that. Again, hopefully you remember this. Dy dt. This is just the same as 1 divided by dx dt. It works quite nicely, just like normal fractions, thankfully. This you can do. Dx dt. Differentiate this with respect to t. And that's what we're going to do in this question. We're going to separate this into 2 early parts. We're going to do dx dt first. Then we'll do dy dt. And then we'll put it all back together and find dy dx. Okay, first dx dt. We are differentiating over here. There's 2 things dividing each other. So we're going to want to use the quotient rule. Let me just remind myself which way around it goes. Okay. The quotient rule tells you, take the bottom row and leave it alone. 3t plus 4. Multiply that by the derivative of the top row. The derivative of this is just 2. 2t becomes 2, 1 disappears. So we multiply that by 2. Then we take away the top row left alone. 2t plus 1 multiplied by the derivative of the bottom row. The derivative of this is just 3. So multiply by 3. All of that then is divided by the bottom row squared. You don't have to remember this, it's given to you in your formulas. Let's clean all of this up. We get 6t plus 8, just multiply that 2 in. Multiply the 3 in, we get 6 or minus 6, minus 6t and minus 3 all over 3t plus 4 squared. Top row the t's cancel and we're just left with 5 over 3t plus 4
squared. That's our dx dt. Let's now do dy dt. Again, there's a trick here. We have to use quotient rule for this one. For this one, we're going to have to use the chain rule. We're able to do natural logs. That's easy to do. We're able to do functions that look like this. That's easy to do. But when they're combined like this, we're going to need to use the chain rule. So how I like to think of this is, imagine if what was in here was just u, just something simple. Just something simple here. We can differentiate this. The 2 we can ignore. We can leave that outside. So we're just asking you, what is the derivative of natural log something? Natural log x, natural log u, however you want to think of it. And the answer is 1 over the something. So the something here is 3t plus 4. That'd be nice if it was that simple. It's not that simple. We have to use the chain rule. We've cheated a little here. We have to fix it by differentiating this thing we replaced. Remember, the chain rule is, well, it's this pretty much, except to put a u here and here. So we've differentiated with respect to u, and then we have to differentiate u with respect to x. Or in this case, it'll be t and different things. So what is the derivative of this? It's 3. So we multiply that by 3. Clean this up, we get 6 over 3t plus 4. Right, I think I can squeeze in the last bit. I'm going to put in dy dx from this line here. Dy dx is equal to dy dt, this one here, 6 over 3t plus 4, multiplied by 1 over this one, multiplied by 1 over this one. That's just turning it upside down. So that's a 3t plus 4 squared over 5. The answer to that is 6 over 5. These cancel in. One of them is gone. Multiplied by 3t plus 4. And you don't have to multiply this in because they wanted the answer to look just like this. They wanted c or some constant multiplied by this bracket. And they asked you specifically to write c is equal 6 over 5. They had state the value of c. So that's full marks for part A.
If you are finding my videos useful and would like to help the channel out, on top of liking and subscribing, probably the best thing you could do is to tell other people doing the exam about my channel. Maybe you could share this video in a class WhatsApp group. Then if you feel I've really deserved it and you would like to buy me a coffee, you could become a member on YouTube or on Patreon. You should find links to that in the description below.
In part B, they tell us it is given that the gradient of the curve at the point a natural log 100 is m. I got rid of the curve I drew. Let's just say it looks like this. So there's some point, it's a natural log 100, and its gradient is m. That's what they told us there. Find the values of a and m. Usually that's easy. We have dy dx right here. So we just get dy dx at x, we nearly always use x, at x equals, they told us it's a. X equals a. The problem is there's no x in here, so we can't put x equals a and get some answer. So that's a dead end. The thing is that we don't often do, but we can do, we could also put in y. If we knew what y was, and we do, natural log 100, natural log 100, put that in. Oh. Another problem though, we don't know what y is either. So we can't do either of those. We need to put in t. So basically I need to find out what t is from this information. This is the point we're interested in. So at this point, what is t? And it's all up here, thankfully. Let me do the wrong one first because it doesn't work out. I'll say this one here, x is a, is equal to 2t plus 1 over 3t plus 4. You could try multiplying this out, but at the end of the day, there's 2 unknowns in one equation. Doesn't work out for us. That's not the correct equation to use. That's because this is a is an unknown. Whereas y? Y is just a number. Natural log 100. Put that into a calculator. I don't know what it is, but it's just some number. So let's use this one over here. Instead of y, we'll have natural log 100 is equal to 2 times natural log of 3t plus 4. Let's try and solve this. We would love to cancel the natural logs. That'd be great. The problem, this 2 is in the way. How do we get it out of the way? You could divide over, but now a half would be in the way the other side. To get rid of this 2, we move it inside the natural log. It moves in by going to a power. That's just one of our rules for logs. So you need to remember that. I'm not sure, I don't think you're given your rules for logs in your formula. So it's something you just have to remember. Now the natural logs do cancel. We're just left with 100 is equal to 3t plus 4 squared. And I'm going to make a mistake in a moment. Try and keep an eye out for it, because I think it's a mistake a lot of people would have made. I'll go a little past the mistake and just get into a little bit of trouble. I'll still get the right answer if I went instead going, but I'd get more than one answer, and that's a problem. So what do we do here? We get the what squared makes 100. So it's 3t plus 4 must equal plus or minus 100. We can solve for this. T would then, let's say, plus 10. 4 take away 10 take away 4 would be 6 divided by 3. T is equal to 2, or if it was minus 10, that'd be minus 14 divided by 3. They'd be the 3 answers for T. The 2 answers for T. Again, there's a mistake has been made at this point. But let me continue as if it wasn't. What they asked us was to find the slope, dy dx. So let's try that again. One more go at this. Dy dx. We don't know what x is, we don't know what y is, but we now know what t is. T equals 2 is one of the possibilities. We put that in. It equals, put 2 in here, we get 6, plus 4 is 10. 10 times 6 is 60 divided by 5. 60 over 5, or is equal to 12. That'd be one answer. Another answer would be this t equals minus 14 over 3. Put this in, we get minus 10. We'd get minus 60 over 5. We get minus 12. This is not a good answer. There's something wrong with this answer. I'd like you to have a think why it is. Before I tell you that though, I will even just do this one more time. You didn't have to put t in. You could have put 3t plus 4 in, and that's equal to 10 or minus 10. I'll let the cat out of the bag. It's only equal to 10. It's not equal to minus 10. Have a think why that is. I'll explain in a moment. This would be 10 times 6 over 5, which again is equal to 12. 12 is the correct answer here. You need to tell them this is wrong. If you left that in, you're losing marks. You're only losing 1 mark, I think. Oh, sorry, I still haven't found A. Let me explain why this is wrong, first of all. It's not that clear or obvious. Everything I did made sense here. It could be plus or minus 10 at this point, couldn't it? Like to get the square root of both of them. The issue is, what if it was plus 10? There'd be no problem over here. That'd be 21 divided by 34. That makes sense. There'd be no problem over here. It'd be, what did I say, 34. It'd be natural log of 34. 2 times natural log of 34. That's fine. What if it was minus 10? No problem over here again. There's a problem over here. If this was minus 10, natural log of a minus number doesn't work. We'd have to get rid of this one here. We'd have to get rid of that and just have plus 10. We should only get the one answer for them. Sorry, they still asked us for A, so let's go ahead and do that. Where would I get A? Oh yeah, X is A. X is equal to A. So we would have A is equal to 2 times T, which I know is 2. 2 times 2 plus 1 over, well, this is all 10, or 3 times 2 plus 4, that's 10. Let's see, what's that? That's 5 over 10. That's a half. A is equal to half. M is equal to 12. You would have only lost 1 mark if you had that. Well, sorry, that's what I thought. You would have only lost 1 mark if you did this. But the thing is, the next question, part C, sort of asks the same thing. Let me clear it off a bit so I can talk about it more. So part C says, state whether the curve represents a decreasing function, an increasing function, or neither. I think my hands went the wrong way there, just so you know. Give a reason for your answer. It's very similar to reason to what would have lost you 1 mark on the last part. First thing, my drawing is terrible. It doesn't look anything like this, it turns out.
What does a decreasing function look like? It looks like it's always going down, like that, or maybe it looks like that, or indeed maybe it looks like that. It always goes down, it never goes up. Increasing function just looks the other way, goes up, or however it goes up. Like might even go, oh, no, that went up the whole time. It might, yeah, let me do that one more time. It might go up and that. But once it's always going up, it's an increasing function. So, what is this and what's your reason why? I hope I've given you the clue. It's very similar to the previous part. What tells you if a function is going up or down is the derivative, the slope, the dy dx. So all the information you need is right here. Is this positive or negative, or is it both? At first glance, it looks like it could be both. If t is minus 20, then this is a minus number. So it should be both. But the thing is, we now know from the previous part, it couldn't be minus 10, or everything in here wasn't minus 10. What else can it not be? This can't be less than 0. It can't actually be 0 either. So 3t plus 4 has to be bigger than 0. It just has to be. And that means this has to be, well, it's multiplied by just a constant. That means this guy here has to be bigger than 0. It can't be less than 0, so it cannot go down. It can't even equal 0, so it looks like a flat line there. It could never even get a flat line on this function. This function is increasing. It's always increasing. It's an increasing function. That's your answer for part C. Okay, that's it for question 6. If you have any follow-up questions, let me know in the comments. Do me a favor and tell me which section you're asking about. It helps me answer you. Thanks for watching and have a great day. Question 7 starts off by asking you to prove this identity. Sine squared of 2x plus 4 times cosine squared of x multiplied by cosine of 2x is equal and always equal to 4 multiplied by cosine to the power of 4. How do you do these questions? I always tell students just take one side, play around with it and make it look like the other side. On a very rare occasion, it's sometimes easier to play around with both sides at the same time and make them look the same. In this case, we don't have to do that. Take one side and play around with it. I'm guessing you could take this side, break it up, turn it into, I guess, cosines and sines might come out of it in some way. Play around with it and make it look like this side. I think I can see a path to doing that, but it's not the easiest way. The easiest way is to play around with the left side. There's a few things jumping out at me. First of all, there's cosines. There's squares, cosine squares and sine squares. They change quite easily into sine squares, because remember, cosine squared plus sine squared equals 1. That's a very famous one. The other thing that jumps out at me is this 2x's. Again, we're given formulas for them too. In your formula table, you're given sine 2x can be changed into something. Cosine 2x can be changed into a few things. So that's what I would start with. I would change this. There's 2 sine x's here, by the way. Sine 2 sine 2x's. Sine 2x times sine 2x. Let me write it all out again. 4 cosine squared x and cosine 2x. I'll put a bracket around that. I'm going to replace each of these brackets here. Let me cheat by remembering. Again, you have it in your formulas. I'm not good at remembering it. It's okay if you're not. This one turns into 2 sine x cosine x. And an identical bracket, 2 sine x cosine x. That's these 2 brackets. Plus 4 cosine squared x. I'm not changing that one. And I'm changing this. I have a few choices to change it. What did I go with? I went with cosine squared x minus sine squared x. Your choices come about because each of these could be turned into the other. Because again, remember, cosine squared plus sine squared equals 1. So you could you get a few different options here. Any of them you wrote should work out in the end. You might just need an extra step somewhere. Okay, let me multiply this back out again. This is just 4 There's two sines, so they're sine squared. There's two cosines, so they're cosine squared. Plus this is times two things, so 4 cosine squared times cosine squared is 4 cosine to the power 4. That's good because we know that we want that in our answer, so this is looking good. 4 cosine squared by sine squared is minus 4 cosine squared sine squared x. Oh, I wrote them the wrong way, so it's not as obvious, but this guy is identical to this. 4 sine squared cosine squared. 4 sine squared cosine squared. So plus there, it's a minus there, they just cancel. We're left with just this, and that's what they wanted us to show. So that's full marks for part A. If you are finding my videos useful and would like to help the channel out, on top of liking and subscribing, probably the best thing you could do is to tell other people doing the exam about my channel. Maybe you could share this video in a class WhatsApp group. Then if you feel I've really deserved it and you would like to buy me a coffee, you could become a member on YouTube or on Patreon. You should find links to that in the description below. In part B, they give us an equation, this equation, in fact, the left hand side here, plus 5 equals k. Find, well, they don't ask to find solutions, they want, who cares what they ask first? Let's write the question down. I'm going to save myself some ink. Instead of writing this part of what they gave us in part B, I'm going to write this. So it's 4 cosine to the power 4x. Then they added 5 to it and they said it equals k. Okay, the question says find the set of possible values for the constant k, for which this equation has no real solutions. So it could have real solutions or no real solutions. Right, how do you go about doing this? There's sort of two ways you could do this. One of the ways will give you half the answer and get you a little bit stuck. So let me do that way first before doing the better way. If I think not real, one thing that jumps out to me is the square root of a minus number. And we do have squares here, a power of 2, power of 4 in fact. Power of 4 is just power of 2 twice, so we have to the power of 2. So if you rearrange this, you could get cosine let me write it like this, cosine squared x squared, don't have to write it like that, would equal k minus 5, that's this, divided by 4. So something squared, when is it not real? Well, it'd be not real when k minus 5 over 4 is less than 0. And multiply everything by 4, we get k minus 5 is less than 0. 0 times 4. So we get k is less than 5. That is half the answer. It is perfectly valid what I wrote, but you'd probably leave that as your answer and move on and lose a mark, because it's not the whole answer. It's not the way they wanted you to think of it. There was another way to think of this. They wanted you to recognize what cosine is. Let me draw a picture of cosine here. Looks like this. This is the only valid numbers for cosine, between 1 and minus 1. Cosine to the power of 4 does look different. It's 1 by 1 by 1 is actually still 1. 0 by 0 by 0 is still 0. It looks different though, because minus 1 by minus 1 by minus 1 by minus 1 is actually plus 1. So it doesn't actually look like this. It looks like, let's see, it probably, starts here. Let's see, it'd go down faster and it would look like this. Yeah, it would look something like that. It'd be still a wave. Let me draw it again here. It would still be a wave, but it would just bounce off the 0 line, is what cosine to the power 4 looks like. Multiply by 4 and we get the highest point now is 4 and the lowest point is 0. So they wanted you to recognize this and basically to say that let's see, 4 cosine power of 4x is equal k minus 5. They want you to recognize that k minus 5 has to be, for it to have no solution, has to be bigger than 4. Has to be bigger than 4 to have no solution. So k has to be bigger than 9. And they also want you to recognize, which is sort of what we did before in a different way,
they want you to recognize that k minus 5 has to be less than 0 for it not to be real, or k is less than 5, just like we found out there. So there are your two answers. If you had these two answers, you're fine. Right, on to part C. They give us this terrifying looking integral to solve, but I really hope at this point you recognize, because if you didn't, you're pretty much, well, you're in trouble. You hopefully recognize that this here is nearly identical to up here. So that you just need to replace this with this one here. Instead of 2x, there's a t. Instead of x, there's a t over 2, which is the same thing. Instead of 2x, there's a t. Basically, it's 2x equals t. It's anywhere you see an x here, well, rearrange that, x equals t over 2. Anywhere you see an x, you can put t over 2. So we can write all of this out again. Let's see, the integral, I won't bother writing all of it. The square root, put that in power of a half. Instead of all this, we can write 4 times cosine to the power of 4 of, instead of x, t over 2. This is what we need to solve. I better put this in, I suppose, for completeness. This is what we want to solve. We can even clean it up a bit more. Yeah, let me put it in over here. The square root of 4 is 2, and that 2 can come all the way outside. So 2. The square root of something to the power of 4 is just something squared. So t over 2. Again, that's pi over 3 and minus pi over 3. So now this is what we have to solve. A lot more manageable looking, I hope. But still, a lot of students might get stuck here. How do you integrate cosine squared? It feels like it should be easy. It feels like the chain rule should work. Chain rule works great in differentiation. In integration, not so much. Substitution is really what the chain rule is, and it only works when things cancel. And it doesn't cancel in this case. You could try it, doesn't work. You could try substitution by parts, two things multiplying each other, doesn't work. At this point, you need to know the trick. You need to recognize there's a trick to solving cosine squares and sine squares, in fact. Both very similar. For sine squares, just change it into a cosine squared. And once you're at cosine squared, you can change it. It's the same thing we used earlier. Let me write the formula out here. We used the formula for cosine 2a. We changed cosine 2a into, I think we changed it into cosine squared minus sine squared. But another option would have been 2 cosine squared a minus 1. That was, yeah, we didn't use that one, but that was one of the options. It's in your formula table. Rearrange all this though, and we get cosine squared of something, of a, is equal to cosine of 2a plus 1 over 2. If we use this identity, this change, this question becomes a lot easier. So let's try and use it. This becomes the integral, again, I hate having to write these every time, but I feel like I'm cheating when I don't. So instead of all this, instead of cosine squared something, I write cosine 2 times this. What's 2 times this? It's just t. Plus 1 over 2. So there's a 2 outside as well. Well, this 2 is just a constant. It's multiplying. It's like a half multiplying, or dividing. It's the same as multiplying. So this 2 can come out and they just cancel. Gone. So we're just left with, sorry, I've left off dt a few times. Speaking of cheating and doing it wrong. Here we go, dt. Now we're just doing these two integrals, cosine t and 1. And both of them are quite simple integrals. The integral of cosine is just sine. The integral of 1 is just t, or whatever you're integrating by, plus t. And this is evaluated between pi over 3 and minus pi over 3. Just put the both of these in. Let me cheat and look at my notes. When you put in sine of pi over 3, that's 60 degrees. I thought it might have been the half one, but no, it's the messier one. You put this in, you get square root of 3 over 2. Put it into t, it's just pi over 3. And then minus you put this in. You put that in, you get minus 3 over 2, so the two minuses cancel. Minus, you put this in, you get minus pi over 3, again they cancel. We have this plus this then, so the 2 is just this way, we have square root of 3. These two add together, get square root of 3. These two add together to get 2 pi over 3. And that's your full marks. I think that's the last part of question 7. And not too bad if you knew the tricks. If you didn't know the tricks, you're a bit stuck. You are just expected to remember how to integrate cosine squared and sine squared. It comes up every now and then, not guaranteed, but it can come up. And if you don't know this trick, it's impossible to do. And if you do know it, it's quite easy to do. So please try and remember it. Okay, that's it for question 7. If you have any follow-up questions, let me know in the comments. Let me know which part of the question you're asking about. It helps me out. Thank you for watching and have a great day.